With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, figure shows two adiabatic vessels, each containing a mass m of water at different temperatures. The end of the metal rod of length L, area of cross section A, and the thermal conductivity K are inserted in water as shown in the figure. Find the time taken for the difference between the temperature in the vessel to become half of the original value. The specific heat capacity of water is given to us is S, and neglect the heat capacity of the rod and the container and any loss of heat to the atmosphere. So in the given question we have been given two containers. Suppose this is container number 1 and this is container number 2, containing equal quantity of water having mass m at different temperature, let us suppose T1 and T2. A rod of length L, area A, and thermal conductivity K is connects the two vessels. Okay, now we have to assume that there will be no loss to the atmosphere, so the amount of energy transfer will be conserved, correct? Now we have to tell in what time that the temperature difference will become half the original value. That means if the temperature difference initially was T1 minus T2, then in how much time it will becomes T1 minus T2 upon 2, correct? So we have to calculate the time, correct? Now what we can say is the vessel is given to us is adiabatic and there is no loss of heat to the atmosphere, so consider we assume that T1 is greater than T2 in this question. Okay, so the loss of heat by the water in container 1 will be transmitted by the rod, and that much of heat will be gained by the water in the container number 2. Okay, so first of all calculate the rate of heat transferred through this rod. So rate of heat transferred through rod. Okay, so it will be given by delta Q upon delta T is equals to T1 minus T2, that is the temperature difference, into thermal conductivity into area upon the length of the rod, correct? This much of heat. So the amount of heat that it will conduct is T1 minus T2 into Ka into delta T upon L, correct? Now the heat lost by the water in container number 1 is heat lost by water in container 1, correct? So delta Q will be ms time delta T, that is the change in the temperature. Let us suppose that the final temperature of the water in container number 1 is T1 dash and in container number 2 is T2 dash. Okay, so delta Q will be given as ms final temperature, initial temperature minus final temperature, correct? So this much of heat will be lost by the water from the container number 1. Okay, and this much of amount of heat is conducted by rod. So what we can say is ms T1 minus T1 dash will be equals to T1 minus T2 times Ka upon L into delta T, correct? From here when we calculate the value of T1 dash will come as T1 minus Ka into T1 minus T2 into delta T upon MSL. Okay, so we have calculated the value of T1, suppose it equation number 1. Now calculate the heat gained by the water in container number 2. So heat gained by water in container number 2. So delta Q will be ms delta T is equals to ms T2 dash minus T2, correct? Now this much of heat will be gained, that is transferred through the rod. So what we can say is ms into T2 dash minus T2 will be equals to Ka T1 minus T2 into delta T upon L. Correct. From here, when we calculate the value of T2 dash, the T2 dash will come as T2 plus Ka times T1 minus T2 into delta T upon MSL. Okay, MSL. Now, this is the equation number 2. Correct. Now, calculate the change in the temperature. Okay, so find the change in the temperature. What we can say is change in the temperature. What we can say is change in the temperature will come that T1 dash minus T2 dash. Correct. Now from here what we get is T1 minus T2 minus of 2Ka T1 minus T2 into delta T whole divided by MSL. Okay. So on rearranging this term what we get is T1 minus T2 minus of T1 dash minus T2 dash will come as 2Ka T1 minus T2 into delta T upon MSL. Okay. So what we can say is this is the initial temperature difference upon minus final temperature difference. So we can say the delta T is the divided by delta T will be the rate of change of the temperature difference from initial to final. Correct. So it will come as 2Ka T1 minus T2 upon MSL. Correct. Now vary the delta T as 0. So what we can write is dt upon let me correct it. Dt upon dt will be equals to 2Ka T1 minus, or what we can say is T1 minus T2 upon MSL. Correct. Now on rearranging the term what we get is dt upon T1 minus T2 will come as 2Ka upon MSL into dt. Correct. So the temperature difference will go from T1 minus T2 to T1 minus T2 upon 2. Correct. And the time period will go from 0 to T. Correct. On integrating it, what we get is ln2 will be equals to 2Ka times T upon MSL. Correct. From here what we can get is the time period. Correct. So time period will come as MSL into ln2 divided by 2Ka. Okay, so this is our required answer. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.